This is a backlit view of it, and you see how much of it there is. There's plenty to work with. The testing on this is going to be like the testing on Otzi the Iceman when they're finally allowed to do it, when they finally have to acknowledge that this thing is real and what it is. Now, as far as that acknowledgement goes, we need a DNA test, and I can finish in about 5 minutes, I think, if I really work it. You have to understand macro to micro in 5 steps. Human body contains 100 trillion cells. There is a nucleus inside each human cell. Each nucleus contains 46 chromosomes arranged in 23 pairs. 1 chromosome of every pair is from each parent. The chromosomes are filled with tightly coiled strands of DNA. Genes are segments of DNA that contain instructions to make proteins, the building blocks of life. There's one more that goes out here. Base pairs arrayed in genes. Thymine, adenine, guanine, cytosine. These two go together, these two go together. And they are the building blocks of the genetic code of the genome. In the nucleus of all of us, except for our red blood cells, there are 3 billion base pairs, approximately 3 billion base pairs. Keep that number in mind. All right, nuclear and mitochondrial DNA. When you cover DNA, you can cover 2 types. There's this mitochondria, there's the cell, there's the cytoplasm, and there's the nucleus here, and that comes from mom and dad. Remember the 23 chromosomes from each? The whole 3 billion is in here. Out here are the mitochondria, and they're about 16,000 base pairs long, 16,000. They come only from females. So the mitochondria that you carry in your body comes from your grandmother, your great-grandmother, your great-great-great-great, back hundreds of generations with very slight changes. That's how they know that we exist as a species only about 200,000 years, by clocking the changes in our mitochondrial DNA. We're very new on this planet, as we are as I'm standing here talking to you. All right, when you do gel sheets, you've all seen it on TV and movies. They squirt the sample out into the gel sheet, and it takes up wherever it belongs. And through a miracle of science, they know what's what. They're able to read it, and they're able to tell different things. Now, we're going to look at the real ones from the Starchild and the adult mitochondrial DNA. The adult, as you see, and here's what they do to tell in real life that they have a working gel sheet. They put the experimenter's DNA in. That's Jason Eshelman's DNA. And these little nicks here that you see are called primer-dimer, just to make sure the gel sheet's working and that they have a live one. This is the adult's mitochondrial DNA. It's from haplogroup A, a very common Mesoamerican group, not a problem. Haplogroup A, nothing unusual about it. With the Starchild, its mother, its mitochondrial DNA, its mother, grandmother, right on back, is haplogroup C. Primer-dimer, Jason Eshelman's DNA. But this combination of 4 is haplogroup C, which means we were wrong up until then to assume that that woman with the Starchild was the mother. We assumed that dramatic thing, hand on arm, had to be the mother. Not so. Not its mother. Friend, caretaker, lover, something, not mother. Big surprise for us here. Now, the nuclear DNA. This is the big one. Nice, clear recovery, no problem. Jason Eshelman, and this is the human. Very different than Jason, as you see, but human, no problem. First time, just as in Canada, easy recovery, and as you see, bright and clear, no degradation. This is prime time DNA. No problem, right? So now it's time to do the Starchild. This is it, the money shot. All the chips out on the table, make or break. This is it. This is it. What is it? Jason Eshelman's, primer-dimer, and in 6 attempts, no recovery. Not 1 attempt, not 2, 6 attempts, no recovery. What does it mean? Mom is human. We know mom's human. Got her mitochondrial DNA. Mom's human. Dad is not. Dad is not human. Now, the problem was in 203 with primers, all they could say is, we know you have something here, but we can't say how far he is, the Starchild's father, or the Starchild itself, and we don't know if it's male or female. We don't know how far away it is. And we can't tell you. So we can't say anything other than you've got something here, but you're going to have to sit on it for 3 to 5 years. Because we know there's technology underway because they want to recover the Neanderthal's genome. You're going to have to wait 3 more years, 5 more years. Oh, God. But I did. I've sucked it up, and here I am. In 206, 3 years later exactly, 454 Life Sciences in Branford, Connecticut announces that they can do it. They can do it. But we can't pay for it because they've been working on the Neanderthal ever since. They're up in the range of $10 million now in the last 2.5 years, and we couldn't do it. But now, today, if we had the money, it would cost $250,000 and we could have an answer in 3 to 4 months. right? It's within reach now. And I had a deal worked out with a British production company to do it in the latter part of last year. And then the economy collapsed and the deal is unraveled. And now what the British and the world companies are saying, you pay for the testing, we'll be happy to do the filming. Well, that's stupid, because it's just, you know, you're just paying them to take over your whole project. Not going to do that. We're going to get all the money and produce it ourselves. There's no point, you know, I don't need them if I get the money for the test. I might as well get it all. It would be stupid to do otherwise. But we're going to do that. Why? Why do we have to film it? Because if there's ever a test that every step has to be filmed, this is it. Because if we get the answer we know we're going to get, the first thing they're going to say is, well, you must have done something wrong because we don't accept this answer. This can't be true. But if we've got the filmed record of it and we show every single step was done properly, they can't argue. We can beat them with this, folks. We can absolutely win. And when we do that, I'll tell you what we're going to get. We're going to get an answer that'll be significantly away from zero. Okay? Because a chimp is 3% away from human. A gorilla is 5%. A chimp is 97% the same. Gorilla is 95% the same. The Neanderthal is going to fall somewhere within that 0 and that 3%. Somewhere in there the Neanderthal will fall. When you look at the physiological differences of the Starchild, you've seen how many I've stacked up. Every one of those is a suite of genes that are different from a human being. I am betting that it's going to be probably beyond 3%, could be 5%, could be 10%. It could be so far that there's not even a blink of a question that this is an alien. Scientists say to me, people say to me, well, how are you going to say it's an alien when there's no alien to compare it against? I'm going to give them the alien to compare it against. I can do it. Now, I will tell you, if that answer comes in at 99.5, you know, where it's only a 0.5% difference, there's going to be some arguing then. If it comes in at 1%, now remember, humans have to fall within 99.99. We're all very much alike. So you can argue it at a 0.5%, but at 1%, it gets a lot harder for them to argue and a lot easier for us to argue. If we slip over wherever the Neanderthal is, you see what I mean? 1, 2, in that range. But I think based on the amount of physiological differences, and if you extrapolate that down through the whole body, I think we're going to do it, and I think it's going to be a huge difference, an undoubtable difference, and I think we're going to win this. In fact, I'm sure of it. If you can't get the hardback book here, if you want to order it later, go online and want to, it's Amazon.com. But I urge you, if you can, get the hardback. It'll have some value to you. This is going to be it. This is the smoking gun. This is what all of you have been waiting for all these years. This is it. It's coming down the pipe. Look for it. It'll be here. Thank you very much.